So a little project I'm working on. It's kind of an extension of an older project I've had going for a while. I need to make a box with a window in it, and it has to be very resilient. Um, so bear with me while I remember how to. There we go. Okay, so it's got three parts: the rear part of the enclosure, the front part here, and then a glass window. So if we turn off those two, we can see that there's some weird geometry on this edge here, and likewise on the front bit, um, there's some detail inside there. Um, so if I turn on the sketches, we have a look. So there's the rear piece here, the front piece here, and then this is the window here. So this is a sketch that gets rotate extruded to form the 3D shapes. So I've got there's a few interesting little details here. Um, Wherever the metal, which is probably going to be aluminium, meets the glass, I've avoided point contact. So this edge here is rounded, and there's these cutouts here, and likewise here. There's a 0.1 mil gap here for a gasket. It's probably going to be made of some sort of ductile metal um, that's not reactive with aluminium long term. I think gold is probably going to be my best option there, but I'm looking for cheaper options. I just realized I need to round over that edge there, and probably that edge there, and those two. Um, so yeah, the idea is that this whole kit and caboodle will be put into. Uh, I'll turn it up on the lathe, and then the void in the back of the rear section houses some electronics. So I'm going to have little solar panels, some supercapacitors, some protection diodes, and a little microcontroller and an LED. So that's all going to sit in there, and it's going to get potted in there for a couple of reasons: to make it a bit more robust and to give it a bit more thermal mass. Is the thermal mass because I'm going to be welding these two bits together around the edge, TIG welding them. So I'm going to clamp it all up in a vise, deforming the ductile metal O-ring at the front, and then weld up on the sides. And then I'm going to have to be actively cooling it between welds, trying to balance the thermal stresses and the thermal effect of cooking the electronics inside. But the goal is to make a really tough little thing, and I'm going to have solar power. It should last for a very, very long time, and it's going to blink out some messages with the LED. So looking at using a AT-Tiny 10 or something in that range, and a fairly low voltage, maybe a 2.5 volt solar panel, because the AT-Tiny can run all the way down to 1.7 volts. So we should get some pretty good runtime out of that. I'd be happy with an hour, but I suspect I'd get far more. And should get many, 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 many cycles out of those supercaps. And there's some research that's been done on longevity, and it's in the millions of cycles if you are pushing close to the current limit for the capacitors. I'm going to be a long, long way from that. I'm going to be charging it at most maybe 150 milliamps, as opposed to the several amps that these will be rated for. So I should get quite a lot of cycles out of it. Probably, I'm hoping in the tens of millions or hundreds of millions. But yeah, that's the project. So next up, I'm going to work on the circuit board that's going to sit down the bottom and get potted in with all the supercaps and surface mount stuff on it. Okay, that's it. Bye bye.